Hello everyone, welcome back to yet another video in the Java 8 series. So today we are going to talk more about the behavior parametrization with very good examples. Okay, and in the end of the videos we are going to see some real examples in the Java library where we use this behavior parametrization. Okay, so let's begin. So consider an example. Okay, suppose you are staying with your friend in a PG. Okay, so your friend knows how to drive a car. So what do you tell him? So you might give him instructions like whenever you are coming back from the office, okay, go to the market, you will give your list, you bring me this, bring me that, okay, and then come back to the home. Okay, so these are the instructions which generally your friend would follow. Now suppose one day what would happen is you have to pick up some parcel, okay, from the post office you have to pick up some parcel. So what do you call your friend and say? Okay, you call your friend and say, okay, now today you have to go to the post office, I'm giving you this number, okay, some tracking number, and please go and pick up my parcel, okay, on your way back to home. So this is something which normally your friend is not doing, but you are passing some extra instructions to your friend to do this work. Okay, so now the behavior, so earlier your friend was doing something, now the behavior is changing, right? You have changed the instructions. So based on that, the person is same, your friend is the same person, but based on the instructions you are giving, his behavior is also changing, right? Earlier he used to go to the market, now based on your changing instructions, he is going to the post office. Okay, so that is something like the same person is executing two different behaviors based on the different instructions we are passing to them. So that is the same idea of behavior parametrization when it comes to methods. Okay, so now we are going to see a very good example. Okay, so suppose you have a list of apples. Okay, so now we are going to see based on the different changing requirements how we are going to evolve with our code, and how we will towards the end we will see how the lambda expressions have come up because of these changing requirements. Okay, we will see how it is beneficial to use the lambda expressions when it comes to changing requirements. So changes in requirements, as you all know, these are the code is never going to be the same, the requirements are not going to end. So there will be some of the other changes that come up during our development process, right? So yeah, so that is the way of life of a software developer. So let us quickly go ahead and have a look at this example. So now we have this apple class, so which is having string color and one more parameter for weight. Okay, what is the weight of the apple? The other one is what is the color of the apple. Okay, we have a constructor which is setting the color and the weight, and then we have some getters and setters. So now this is the apple client which is having this main method and also some pre-filled apples in the list, and we are going to use this for our further example explanations. Okay, so consider the first use case. Okay, so our first use case would be, so we are asked to filter based on the color. Okay, I'm just saying I want the green apples. Okay, so we are going to filter based on the green apples. Based on the color of the apples. Bye. So this is the apple client, and here we have some list of apples, okay, some pre-filled data, and we are going to use this inventory for understanding our example. Okay, so consider the first case. Okay, the first case we have to filter this inventory list of apples, and we have to filter it by green apples. So we want only green apples. Okay, so suppose now you got this requirement wherein you have to write a function, some filter function, wherein you will filter out just the green apples. So how would we do that? So our first attempt would be in this way, right? Anybody would try doing this. So we are just filter green apples. Okay, here we are going to take the list of apple as the input parameter, and then we are going to iterate through the list, right? So this is the first thing that would come to anybody's mind. So we are going to iterate through the list, and we are going to see if we are going to get the color green. Okay, and if it is green, so we are going to create another list here, something like result, and maybe a new array list. Okay, and then we are going to add this apple to the list. Okay, so in this way we would generally write any method, right? We are returning the list. So here what we would get all the list of apples which are green in color. And how we would check that? So let us write some system.out.println statement wherein we are creating our Apple client instance, and then we are calling the filter green apples, and we are passing the list of apples. Okay, so here we are iterating through the list, and then we are getting the color of each apple and comparing if it is green or not, and then we are returning. But do you think this is the ideal way of writing this? Because suppose tomorrow again, if you get a requirement saying now we do not want green apples but now we want red apples, then what you're going to do? Okay, so that would be our second case. Okay, filter red apples, and now we are going to, so the better way of doing this is, so instead of hard coding this green, we can ask the client to pass which color of apples do you want to filter out. Okay, so instead of having this method in this fashion, the better way would be obviously to have some string parameter, as color is a string. Okay, so we can pass in the color. So instead of this equals green, we can just compare with whatever color we want, right? Either green or red. So instead of having two different methods, one for filter green apples and the other for filter red apples, so here we can have filter apples on color, or some based on color. Okay, so this way it is like somewhat better than the first attempt, right? Here we are hard coding the color, and here we are not hard coding the color. So here how we can do? So we can call the filter apples. I doesn't sound good. Let us make it by color. Okay, now along with the inventory we are passing in the color to filter out. Okay, let us just run this. Okay, so the first one we got the green apple, the first filter method which we have written, and the second one we got like the list is filtered based on the color red. Okay, so this is one way. But now what could happen? Okay, so our third case, now we are saying we don't want to filter by color, we just want the apples which are heavy in weight. Okay, so we want a filter which would filter by weight, and also by color. What we would do at that point? So the first thing which would come to our mind is, okay, we have the list, we have the color parameter, why not add another parameter for weight also? Okay, so that would be the general tendency, right? So here what you would do, okay, now filter by color and weight, and we are passing color as well as weight. Okay, so here what we would do, we would check the color. If the color is passed, okay, that conditions also we might have, and then we are going to like get the apples which are greater than 150 grams, something like that, and then we are going to return. Okay, so how we are going to call this out? Now instead of just the inventory and passing out the color as a parameter, maybe let's pass green. We are also going to pass the weight. Okay, so here not the 150, the weight, what weight we want, suppose 150, and filter by color and weight. Okay, so now let us run this as well. Okay, we do not have any green apple with one greater than 150 weight. Okay, so maybe let us add another apple. Okay, we'll run it again. So we have one green apple with weight 250 grams. So now if you carefully observe these three methods, okay, so you can see that we are like everything is common, okay, till the for loop, beginning of the for loop, and the way we are returning the result. In all the three methods, this part is common, right? What is changing? Only the if condition is changing, okay? Only the if condition. Here we are just checking the color, here we are checking color based on what we have passed, and here we are checking the color as well as the weight. Like, but then again you will have, here you just have two parameters, but generally we are not going to have just two, we will have multiple parameters. So what we are going to do in that case, how many such parameters you will keep on adding, and how will you check if they are not the mandatory parameters, and checking those conditions also will become complicated, right? So what do we do in that case? So the better way of doing this would be to have some interface, and then we would have some concrete implementations. So now that one so this one if condition, okay, only this is changing, so why not take that out and then pass that as parameter to our methods. Okay, this changing condition in all these three methods, why not take it out completely and pass that as a parameter itself. So for that we can create this interface, okay, something called as apple predicate, which would have one method, okay, which is returning boolean. Name of the method is test, and it is taking the apple as an input. Okay, so the concrete implementations of this would be, to filter based on the color, okay, or to filter based on the weight. Okay, so those concrete implementations would then implement this method and give their respective behavior. Okay, so now when we have our conditions separated out in different concrete implementations, so in future if you have like more parameters to test, then it becomes a bit easy than to change the existing methods which we have here. Okay, so it is easier to add these new conditions, new concrete classes, than changing this existing method. So now we can have, suppose we can have a new class. Okay, so suppose if you want to get just the green apples, so what you can do is you can write some apple green color predicate that is implementing this apple predicate, and you are overwriting that method. Okay, and we are saying return the green color apple in this method. Okay, so that if condition which was changing in this different methods, now that we have taken it out, and now we will see how we will pass it as a method parameter. Okay, similarly for the weight, we can have like apple heavy weight predicate, wherein we are checking if the weight of apple is greater than 250. So okay, this condition also we have taken out. The which was there in the if condition, now we have taken it out. So now how we can do it? So this would be our fourth case, wherein we are taking the condition out as a new behavior, we can say. Okay, so what we can do is new apple client, the same thing, dot filter. Okay, we have to first write the method, right? So here what we can do is, here also we are returning list of apple. What is happening? Okay, then filter apples. Okay, and here also we are passing the list of apple, and apart from that, now we are going to pass implementation of this apple predicate as a test. Okay, what exactly we are going to test? So here also we are going to have this result array list. Okay, and the same for loop. And now what we are going to do is, we are going to let us not name it test, let us name it condition. Okay, so we are just condition dot test, whatever is the implementation, we are going to pass this apple. Okay, if it is passing the condition, we are going to add to the list. And we have to return the list. Okay, so now what we are going to do is, now instead of having these multiple methods, okay, instead of having these multiple methods for every changing requirement, now we have at least this filter apples method fixed. Okay, now this we will not need to change, because based on the conditions which we can pass here, we can use the same method, and then based on the condition the filter operation would work, right? So now we don't have to write multiple implementations for filtering out the apples. Okay, so this one method would be sufficient to filter out. So what is the thing we are changing here? Only the behavior of the condition. Okay, based on what condition we are going to filter, only that is changing, right? So now our method is going to be fixed here. Only this condition would be varying, because as we have observed, that condition itself was varying. So now that condition we have taken out, and we will be passing it as a parameter. Okay, now that behavior, we are passing it as a parameter. So let us see, let us continue writing this. Did I? Okay, see, this one C is causing that. Filter apples. Here we are going to pass inventory, and suppose now if you want green color apples, so you will just create an instance of that implementation of green color and pass it on. That's it. right? So now let us just comment these out. Okay, now we do not need these. Okay, so these were the basic implementations which we were trying out earlier. So with every change in requirement, we had to write a new method, write the additional parameters, or just change the existing method, add more parameters. Okay, that was a lot of code change that was going on. So now with this behavior as a parameter, we are just changing the condition. Okay, now it is a green color predicate. Okay, so if you want a heavy one, so apples which are heavy, right? So there you can pass the implementation of the heavyweight predicate. Okay, right? So suppose if you want another condition wherein the apple is red and also heavy. Okay, so now for that what you will do? You will create another implementation. Okay, apple red and heavy predicate. Okay, so this is another condition which you can add, right? So now what do you see? Let us run this first. Okay, so now we have the green color apples and also we have the heavyweight apple, right? So in this way we are passing. So but here also if you see, we have to create these new classes, right? What is this is also like with every change in requirement you're creating new classes. You're just there is this one method only which you are implementing again and again. Okay, in these classes also if you see, okay, these two lines, okay, is common for all the implementations, right, of that apple predicate. Okay, why to create new classes and do that? Okay, can there be any better way to do that instead of creating classes? Okay, so that would bring us to our fifth case, that is anonymous classes, which nobody likes. Okay, so here what we will do is, so now we have this predicate for green color, right? So instead of creating a new class altogether, new implementation altogether, we can create this anonymous class, right? So filter apples, we are passing the inventory. Now instead of creating a new concrete class, we are going to give the implementation of this apple predicate right here. Okay, we are going to write an anonymous class for it. So here itself we are going to give the implementation of this test method. Okay, so this is the anonymous class which we have created. There is no name to this class. This is the implementation of this interface, of this apple predicate interface. Now we no longer need these new concrete implementation in separate, well-defined classes. We can give the implementation right here, right? Apple dot get color dot equals maybe green. Okay, whatever you want to pass the condition as. Okay, so in this way, in the fifth case, we don't even need multiple classes now. We just have this one apple predicate, and with the help of anonymous classes, whenever we require, we are passing the condition based on our requirement, right? So this is one way of doing it. But as you see, this is like more complicated. It is a better solution, better than the earlier first three cases, right? Far better than the earlier first three cases. But then here also, suppose if you again write another anonymous class just for weight, here also if you see all these things are repeating, right? Why to have this repetition when we can avoid it? Okay, so now with Java 8 features, we can avoid this implementation, right? So suppose if you have to this will make it more clear. Okay, get just a minute. Okay, so suppose if you want to filter by red color. Okay, so here also if you see, we are repeating this implementation part many times. Okay, why do we have to do that? So now in our sixth case comes our lambda expression. Okay, so all this complexity which we have faced, first, second, third, fourth and fifth case, because of all of that, now you'll start loving these lambda expressions. Okay, so how we can do that with lambda expression? Okay, so we are going to, let us print it again. Apple client dot filter apples, we are passing in the inventory. Now instead of creating a concrete implementation of the predicate, we can directly give the implementation of this method with the help of lambda expression. Okay, we are giving the implementation of this method with the help of lambda expression. How we will give that? So we are passing in the apple, we have to use the arrow. Now get color equals red, that is it. Okay, you do not have to create another implementation, you do not have to write anonymous classes. All of that is now removed, like eradicated, right? So directly the condition, if you see here, directly the condition we are passing as the parameter with the help of a lambda expression. Okay, this expression says that this is the implementation of that predicate. Okay, so this is the predicate, and this predicate's condition, the test method's implementation, we are just passing in as an expression. We are not creating new classes, concrete implementation classes of that interface. We are not creating anonymous classes as well. Though that is a good idea. Before Java 8, that was the best idea to do. But now with these lambda expressions, you don't have to have anonymous classes. You don't have to have new concrete implementations of that interface. You just need the implementation, right? So suppose now if you want red color, okay, green color. See how easy it becomes. You just have one method that is fixed and you are just changing the condition in just a single line, right? In just a single implementation, in just a single expression. So this is the beauty of functional programming. So whatever you are saying, so I want apples of color red. So that is just the thing you are writing in the lambda expression. I want apples which are of weight 150 grams. That would be the thing you will directly write in the lambda expressions. You don't have to go in the complexity of writing new concrete implementation. You don't have to go with the complexity of anonymous classes. You're directly giving the lambda expression. Okay, so that is the beauty of functional programming, and that is why these lambda expressions were introduced. So now if you see, one challenge here is your interface should have just one method, right? If you have more than one method, how will the compiler know which method's implementation you are giving in the lambda expression, right? So that is why your function or your interface should have just one method. Okay, so that one method would be referred to when the lambda expression is being evaluated by the JVM. Okay, and these such interfaces we term as functional interfaces, right? So these are the functional interfaces. So it is not mandatory to write the annotation. Okay, but then if you write this annotation, then you cannot add more methods, like you cannot add any other method here. That is not allowed. Your functional interface should have just one method, though it can have default and static methods that we will talk about later in the video series. Okay, so yeah, so this is one thing. Now, not just this, okay, how can you more simplify your filter apples method here? Okay, so let us see that as well. So now you have this filter apples. Okay, so now I don't have an Apple client. Okay, I just have a general client. So with the help of generics, I can have maybe a common predicate, not an Apple predicate. Okay, predicate is a predefined class in the function library. Okay, now with this, what we are doing, we can not even filter, not just apple. Okay, we can filter, you can now filter your oranges, or now you can filter any integer as well. Okay, whatever type of list we pass here and the condition, we can use this filter function as a common utility method now, right? So yeah, so this is the seventh case which you can consider, where you are writing this filter function generic, and you can like use it for filtering any list of any type based on the given condition, right? Okay, so this was all about behavior parameterization. Now coming to some real examples. So suppose if you want to sort this list, okay, so now the sort method is in the list itself. So what we can do is we will call that sort method, and you have to pass in the comparator, right? Based on what criteria we are going to sort it out. So we can define that new comparator implementation as an anonymous class. Let us write it as apple. Okay, return one dot get. Okay, so in this way we are using the comparator as an anonymous class. Okay, before the lambda expressions we used to do it in this way. So now how can we do it with the help of lambda expression? So we can pass the implementation directly now. Apple A1, suppose, apple A2. So these are the input parameters, and here what we are doing, we are just giving the implementation. Let us do the weight. Compared to A2 dot get color. Okay, so now this is a real example where instead of giving the implementation of the comparator as an anonymous class, we are directly giving the implementation with this just one lambda expression. Okay, so this is one example of how we can use the give the implementation of the comparator interface. Okay, the other example would be the runnable, right, where we create when we create the threads. Suppose we are creating a thread T1, and here runnable, how we would do is we would and we had to implement this run method, right? So this runnable is also a functional interface now, and it has only one method, that is run method. So instead of defining it in this way, okay, what we can do is we can directly give the lambda expression. So here we are not going to pass anything, and now we will just give the implementation of the run method, whatever we want. Okay. So now instead of writing the implementation as an anonymous class, we are directly giving it as a lambda expression. Okay, so lambda expressions are basically we are giving the implementations of these methods of the functional interfaces. Okay. And another example you can consider of event listeners, I think we use that also a lot, right? So these are the three basic examples which we have within the Java library where we can use this lambda expressions concept now. I hope you enjoyed this video and gained a lot of knowledge out of it, and you learned what is behavior parametrization. Okay, so our next video is going to be on lambda expressions. Okay, we are going to dive deep into what are lambda expressions and also method references. So I know many people get confused with these things. So in our next video, we are going to dive deep into that. So stay tuned for the next video. And if you want to receive notification for the same, you have to subscribe to my channel and hit the bell icon. Okay. And if you like this video, hit the like button. Thank you for staying till the end. Have a great day. Thanks for watching.